Alright, so we're just doing word problems today. So it's all the same stuff that we've been doing, but you've got to come up with your equations now because they're not going to get them to you. So we'll just work through a few of them and that'll be it. So it says that Nick and Jacob are selling fruit for a school fundraiser. Customers can buy boxes of apples and boxes of pears. Nick sold 3 boxes of apples, 14 boxes of pears for a total of $203. Jacob sold 11 boxes of apples and 11 boxes of pears for a total of $220. Find the cost of a box of apples. So we've got to decide first off what our variables are going to be, because we're talking about boxes of apples and boxes of pears. So we could say like A and P, or we can just use X and Y. What do y'all want to do? I like X and Y, that's just me. So we'll say X is going to be something, Y is going to be something. Which one do we want X to be? Apples or pears? Apples or pears? So again, if you wanted to use like A and P there, you can, that's fine. Whatever you want to label your variables is totally up to you. So then we need to go back and read our problem again and get our equations. So is there a sentence in there that sounds like an equation to you? So we've got 3 boxes of apples. How would you write that? And, what does and mean in math? 14 boxes of pears. How do you write that? 14 boxes. There's a total. What does total tell you? Equals 203. So there's one equation. And now we know that these are going to be systems, so there's got to be another one. The next sentence is going to give us that equation. What do you think we're going to have there? We've got 11 boxes of apples, so that's our 11x. And it says and again, so that means plus. What else? How are we going to write that? And then the total this time was 220. So we've got to find the cost of a box of apples. So when we solve, we're going to want to get what x is, whatever x is. That's going to be our answer. So like we've been writing our answers in order of pair, right? When it comes to word problems, they're going to be very specific and they're going to be tricky and sneaky and try to make you get it wrong. So you've got to read the problem again once we get like our answer and give them exactly what they're asking us for. So if we want to solve this equation, we talked about a bunch of different methods to solve your systems, right? We did graphing, we did substitution, and we did elimination. So which one do you think might work best here? Probably elimination, right? That was when we had the x's and the y's were all lined up. And then we were trying to get a variable to cancel, so you needed to have the same number and the opposite sign going on somewhere. Do we have that with your x's? No. Do we have that with your y's? So what do we do to fix that? Multiply by something. So we got to pick a variable to get rid of. I think x's would be easier in this case because they're smaller numbers. However, what do they want us to find at the end? They want us to find the cost of apples, and for us, apples was x. So, hear me out. If we go ahead and get rid of the y's now, when we solve, you'll have what x is. You don't even have to solve the whole problem. Does that make sense? So do y'all want to do that? Okay, so we'll work a little bit harder up front, but we won't have as much work to do later. So if we're going to try to get rid of our y's, what do we need to multiply by? Yeah, what you think? Okay. Sure. So we just got to make one of those negative. It doesn't matter which one you do. Negative 14. It's okay. Again, it doesn't matter. So if you want to do negative 11 instead, that's totally fine. We should still end up having the same answer. So when we multiply that entire top equation by 11, it might be helpful to have a calculator because that 203 times 11 is going to get pretty big. So if you have yours, great. If not, you might want to grab it real quick. So we'll do 3x times 11, and what do you get? 33x. And then 14 times 11, what is that? So 150, oh, yeah, no, that's right. Yeah, 154y. And then 203 times 11. Goodness gracious. huge numbers. All right, then we're multiplying the entire bottom equation by what? Negative 14, so we'll do 11 times negative 14. What do we get? Negative 154. And then we're doing 11 times negative 14 again, so negative 154y. And then 220 times negative 14. What do we get there? Yeah, negative 3080. So we'll add those two together. So we've got positive 33x minus 154x. So what is 33 minus 154? And what happens with the y's? Cancel that. So then we've got 2,233 minus 3,080. And what is that? Yep, you probably did 380 instead of 3,080. Check it. Then what do we do from here to figure out what x is? Divide by negative 121. And what do we get? X equals 7. So again, that was what we were looking for, right? So if you go back and read the problem, it wants us to find the cost of a box of apples. For us, apples was x. So we found x. Are we all done? Yep. So our answer is 7, and we're done with that. So we have been having to find x and y, right? Because you're just trying to find a solution. But with your word problems, they're going to be more specific, right? And they're going to try to trick you. So we need to be really careful when we're reading these. Do we have any questions there? So we're all right? All right, let's try another one. So looking at number 2, an animal shelter has 64 cats and dogs. The number of dogs is equal to 6 less than 4 times the number of cats. So how many dogs are there? What are our variables going to be this time? We can use x and y again. What is x going to be? Cats? Then that means that y has to be what? Dogs. So we've got to come up with 2 equations. What might be one? Is that what you were going to say, Noah? Yeah. So it says the shelter has 64 cats and dogs. So together, cats plus dogs has to equal how many animals? 64. So we'll say x plus y equals 64. The next one's a little bit tricky. So it says the number of dogs is. Well, what variable were we using for dogs? Y. So we'll say y. And then what does is mean in math? Equals. Well, it says is equal to, so hello, equal sign. Then it says 6 less than 4 times the number. When we see that less than phrase, ding, 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 red flag, what do you have to do? Flip the order. So instead of 6 minus something, what are we going to write? Yeah, so 4 times the number of cats, and cats was x for us, so we'll say 4x. Then we'll write minus 6. Is that all right? Questions on where any of that came from? Okay. So from there, again, our methods for solving are graphing, substitution, and elimination. Which one do you think might work best here? Substitution. Why substitution? What do you think? Yeah, what do you think? Exactly. We've got one variable that's isolated, right? So you've got x equals some stuff or y equals some stuff. So we've got that y equals all of this. And what are we going to put it in place of? Y. So we'll plug that into the top equation. So we're going to have x plus y. But what do we know that y equals? 4x minus 6. And altogether, that's supposed to be 64. So we've got to solve that equation, yeah? What do we need to do? We need to add the 4x and 1x. What does that give us? 5x. And Noah, what did you say? Add 6. I'm going to go ahead and do all that at the same time, y'all. So we're going to add 6 over. So it's 64 plus 6? 70. So we've got 5x equals 70. How do we get x all by itself? Okay, divide by 5. And what do we get for x? 14? So we know that we normally have to find x and y. Let's read the problem again to see if we can be done with just finding x. So it says they've got 64 cats and dogs. Number of dogs is equal to 6 less than 4 times number of cats. How many dogs are there? So what are we trying to find? Y. We need y. Have we found y yet? How are we going to do that? Plug back in. Is it going to be easier to plug into the top or the bottom? I think the bottom, because we're trying to find y, and that says y equals all this stuff, right? So let's just plug in a 14 there. So we'll have y equals 4 times 14, going in place of x, minus 6. Then we'll just evaluate that. So what is 4 times 14? 56. So we've got 56 minus 6. So what is y? 15. And what did we say our answer was going to be? X or y? Y. So 50 would be our final answer there. How can we check that just to be sure that we're good to go? Plug it back in, right? So I think it's easy to plug into the first one. It says the x plus y has got to be 64. So is 14 plus 50 64? Yeah, so we probably check out good there. Is that okay? Questions on that? Alrighty, so let's try another one. So number 3, it says Chris weighs 50 pounds less than his older brother. Together they weigh 210 pounds. So how many pounds does Chris's older brother weigh? So what are our variables going to be this time? So we're going to have x and y, and then we're using Chris and his brother. So we'll say Chris and the brother. So what do they tell us about Chris and his brother? What do we know? So Chris weighs, how do you think we could write that? In like math or algebra. X equals, yeah, because we know that Chris is x. So we'll say x equals 50 pounds less than his older brother. So again, when you see that less than, what do you have to do? Flip the order. So what variable are we using for the older brother? Y. And then less than is minus 50 pounds. Is that okay? What else do we know? Altogether they're 210. How are we going to write that? Good. X plus y equals 210. So now we just have to solve that. What method might be easiest here? I think substitution is going to work well for us again. So we know that x equals all of this stuff, and we're going to put it in place of x down here. So instead of writing x, what are we going to write? Y minus 50 plus y equals 210. To solve that equation, what do we need to do? What's y plus y? 2y. From there, add 50. So 2y equals, what's 210 plus 50? 260. What's our last step? Divide by 2. And what do we get for y? So we know that y equals 130. Let's read the problem again, see if we need to keep going. So we got blah, 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 blah. How many pounds does Chris's older brother weigh? Which variable was the older brother for us? Y. Did we just find that? Do we need to find anything else? You don't have to. So we'll stop right there. Is that okay? Questions? Are we all right with these? Yeah. Anybody else dying? Do you want to crack a window back there? That might be warmer outside there. Alright, looking at the next one. The admission fee at a small fair is $1.50 for children, $4 for adults. On a certain day, 2,200 people enter the fair and $5,050 is collected. How many children attended? What do you think our variables are going to be this time? Children and adults. So we could use X and Y still if y'all like that. X and Y. Which one do we want to be X? The blind doesn't have to stay open. Just get air flow. The blind what do you think X is going to be this time? Children. Children. And then what's Y? Adult. So X is children. And Y is adults. ADULTS. So what do they tell us about these children and adults? 150 for children. How could you write that? What else? So what does and mean in math? Add. 4 for adults, so I'm just going to say 4y. And then what is that going to be equal to? What should I think? Which one? Why would it go with the 5,050 instead of the 2,200? Talking about what? It's money, right? This was money. Money has to be equal to more money, right? So we're going to say equals $5,050. So I'm going to do money, money, money. All right. What else do they tell us? 2,200 people enter. So we know that something is going to equal 2,200 people. Yeah? What are our people that we have attending this fair? Children and adults, X plus Y. Do we know anything specific about either one? No. So can we just say X plus Y equals whatever? Sure. Is that all right? Questions? All right. So what method do you think might help us to solve this? Probably elimination, right? Because we've got X's lined up and Y's lined up. So we've got to decide which variable to get rid of. Right off the bat, which do you think would be easier? Easier to get rid of Y? Maybe because it's a whole number. What does it want us to find? Children. So it wants us to find X, right? So I think it would be helpful to get rid of Y here, right? Because then, like on the one we did at first, we can just find X and be done. We won't have to find both variables. Is that okay? Are y'all good with doing that? Yeah? Are we confused by that at all? Okay. So we're going to get rid of our Y's. So do we have the same number opposite signs right now? How could we make it same number opposite signs? Is there something we can multiply 1 by to get it to 4? Just -4, right? That'll give us same number opposite signs. So the top equation is not going to change, so I'm just going to copy that down. 1.5x plus 4y equals 50/50. Then we're multiplying that bottom equation by -4. So x times -4, what are we going to get? And y times -4 is -4y. And what's 2,200 times -4? Is that right? Yeah, no, maybe? Alrighty, so now we're going to add those two together. So we've got 1.5 minus 4. So what's 1.5 minus 4? Our y's cancel. Then we've got 5,050 minus 880. What is that? And what's our last step? So when you divide by 2.5, what do you get? You're smarter than your calculator. We know that negative divided by negative is what? Positive. Can you have negative 1,500 children? Can we have negative 1,500 children? Let's just use common sense for a second. Is that going to work? No, so you know that if you get that as your answer, probably just make it positive. Is that okay? So we got X, and it asked us how many children attended. Do we know that now?
Yeah.
Yep, so 1,500 children attended, and we are all done. Got okay?
Yes.
Questions?
No.
Moving on. Y'all, this is my favorite kind of problem. I'm so excited. Our farm has chickens and goats. Me too.
They're so cute.
I'm just really pumped for this problem. It's my favorite kind of problem. So you ask the farmer how many chickens he has and how many goats he has. Now he's a tricky farmer, so he's going to give you a riddle. He says that he has 24 healthy animals. They have a total of 58 legs. So how many of them are chickens? Oh my gosh. Chickens do have 2 legs. We got to figure out what our variables are first. So let's start there. What are our variables going to be? X and Y, aka chickens and goats. So, the farmer tells you that he's got 24 healthy animals. So what are our animals that we're talking about? So how are we going to write an equation for that? There you go. X plus Y, chickens plus goats. I almost just read a G. Equals 24. Then he tells us he's got a total of 58 legs. Why would we do 2x? Okay, what else? Right? Isn't it so cool? So when I was doing my student teaching, I was in a school that was, they were like pretty out in the middle of nowhere, but not all kids knew like what farm animals looked like. No, they didn't know how many legs chickens and goats had, and I was like, 58 legs total. Some people don't know. I mean, think about it. Like, if you've lived in a city your whole life, and like maybe you didn't go to like preschool and get to like play with ducks and stuff.
Abby said that chickens
When you eat a chicken, if you cook a chicken, there's super.
But listen, like some people don't do that.
But like in babies and stuff.
Abby said the chickens won't fall. They watch a movie and they don't really have it. What's that?
What's that thing with feathers? All right, so anyway, cool problem, right? And we haven't even solved it yet. But it's so much fun. Chickens and goats. How many animals are chickens? Which variable is chickens for us? X. So when we solve this, which method are we going to use? Probably elimination, right? And we want to know what chickens are, how many chickens we have. So we want to know what X is. Can we get rid of Y? Yeah? So what do we need to do in order for our Y's to cancel? Multiply top by -4. So that's going to give us negative 4x minus 4y. And what's 24 times negative 4? So then we can add those two together. What is 2x minus 4x? Negative 2x. The 4y's cancel. And what's 58 minus 96? What do we do from there? So what does x equal? And let's read the problem one more time just to be sure we're good here. It wants to know, blah, 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 how many of the animals are chickens? 19. So are we all done? Yes. X equals 19. We don't have to do anything else there. Only 5 goats? I would definitely want more goats than chickens, but that's just me. They're real cute.
Yeah, there's good, so.
They feed.
Seriously?
Yeah.
That's hilarious.
All right, let's do. Yeah, we gotta move on to the next one. We're super excited. So a concession stand, or at a concession stand, Parker bought 3 hot dogs, 2 sodas for $12.15. Taxes included in the price. A hot dog cost 80 cents more than a soda. So what is the cost of 2 hot dogs and 1 soda? So what are our variables this time? Hot dogs and sodas. So we'll say X equals something, Y equals something. Which one do y'all want to be X? Hot dog.
Only way you can eat a hot dog is if you load a bunch of crap on it, so you can't actually taste the hot dog.
All right, so Parker bought 3 hot dogs and 2 sodas for $12.15. How are we gonna write that? 3 hot dogs. How'd you write that? 3 eggs. And means what? Plus 2 sodas. 2y. All this equals how much money is it costing him? $12.50. Whoa, 15, not 50. Almost right, 50. What else did they tell us?
Hot dog costs 80 cents more than a soda.
So we know a hot dog costs, so we could say X equals 80 cents more than a soda. So we could say 0.8, and then more than tells you what?
And what is soda?
Add. And then soda, what variable is soda? What method might be best here? I think substitution, because we've got X equals a bunch of stuff. So we're going to take everything that X equals and plug it in place of X in the first equation. So we're going to have 3 times X, but what do we know that X is? 0.8 plus Y. Then we've got plus 2Y up there equals 12.15. How are we going to solve that equation? Y'all know. Distribute. So what's 3 times 0.8? Then what do we do? Combine your y's and then subtract 2.4. We can do all that at the same time. So what is 12.15 minus 2.4? And then what do we do from there? So y equals 195. Are we done? Let's read the problem again. It says, concession stand, 3 hot dogs, 2 sodas, 12.15, taxes included, hot dog cost, blah, blah, blah. What is the cost of 2 hot dogs and 1 soda? So do we have to know both variables this time? Yeah. So we know what y is. We've got that figured out. We still have to find x. So how might we go about that? We'll just plug back in, add 80 cents to that. So we'll say x equals 0.80 plus what y was, which we found was 119, or 195. Goodness, cannot say numbers today. So what is 195 plus 0.80? What is it? 2.75. Is that okay? So we know what x is, we know what y is. Are we done now? No, because we're like placing a whole nother order, right? We want to know 2 hot dogs and 1 soda. So which variable was hot dogs? So we're going to do 2 times x. So we'll do 2 times 275. And a soda. So plus the value of a soda, which was y, 195. So we've got 2 times 275 plus 195. $7.45. That's going to be our final answer. So like I said, they're going to be sneaky and they're going to try to trick you. And I guarantee, if this was like multiple choice, this would be an answer, this would be an answer, this would be an answer, and then you have something else that's completely random, right? But they would put all three of those on there. And how many of you would find Y and be like, oh, that's there, I'm done. Circle that sucker and be like, you got fooled. So just be really careful on this. Questions on that? All right. Okay. So this next one is talking about hardback and paperback, and I always get like tongue twisted on this, so just bear with me. So a used bookstore sells hardback books and paperback books. A hardback book costs $12, including tax. A paperback book costs $6, including tax. Jamal bought 4 more paperback than hardback books. He spent $60, so how many paperback books did he buy? We've got to decide what your variables are. So do you want to use X and Y again? Yeah? Which one's going to be X? And Y has to be paperback then? So what do they tell us? What's some helpful information we've got? So hardback is 12. What else? Paperback is 6. What else? That's money. Did they tell you anything else about money? Spent $60 total. So let's write an equation for that. If hardbacks are $12, how would you write it? 12x. Plus, paperbacks are 6, so how would you write that? 6y. And how much money did he spend total? 60. So we got money all together. What else did they tell us? So we know that paperback, he has 4 more of those than hardback. So we can take hardback plus 4. Is that okay? Yes, no, maybe? Do you have any questions on how we set this up or where this stuff came from? You will see this again. So are we okay with this problem? Any questions, doubts, concerns, confusions? Okay. What's going to be the best method to solve this one? Probably substitution. So we'll take all this stuff that y equals and plug it in place of y in the top equation. So you're still going to have that 12x plus 6, but what do we know y is now? X plus 4. All that's supposed to equal 60. How are we going to solve that equation? Distribute. Then what do you do? What's 60 minus 24? And 12x plus 6x? What's our last step there? So what does x equal? Let's read our problem again and see if we're done. It wants to know how many paperback books did he buy? Which was paperback? Y. Do we know y yet? No. So we're going to have to plug that in to find it. Is it going to be easier to use the top equation or bottom? I think that one would be super easy. We want to know what y is, so just plug in 2 for x. So y is going to equal 2 plus 4, and what is that? 6. So our answer is what? 6. Is that okay? Questions? And again, I would bet money on it if this was a multiple choice problem. They would have both 6 and 2 as answer choices. So you've got to be careful when you're answering the question and make sure that you pick the right thing or that you give them the right answer, exactly what they're asking for. Any questions on that? All right, last one. We're almost done, y'all. So this one, I think they're kind of neat because it just says the sum of two numbers is 66. So what does sum tell you? Add. Do we know what the two numbers are? So what do we use for placeholders? Just X and Y. So some number plus another number is supposed to be what? 66. Then it tells us that their difference is 8. Well, what does difference tell you to do? Subtract. So same variables, x minus y is supposed to be 8. Now we want to know the value of the smaller number. Well, just by looking here, we can't really tell which one's going to be smaller. We don't know. So we'll probably need to find both x and y just to be sure. Okay? What method is going to be the easiest to solve that system? Probably elimination. Do we have anything that's same number, opposite signs right now? Yeah, the y's. So let's just add these together. Those y's are going to cancel out. And we'll have 2x equals, what, 66 plus 8? 74. And then what do we do from there? Divide by 2. What does x equal? So we've got x is 37. We still need to find y just so we're sure we know which one is smaller. So how are we going to do that? Plug 37 back in. Do y'all want to use top or bottom? I want to use top only because it doesn't have a negative. And sometimes we mess up with negatives. So let's plug it into the top. So we'll have 37 plus y equals 66. And how are we going to solve for y? So y equals, what's 66 minus 37? 29. So let's read the problem again, make sure we got the right thing here. So sum is 66, the difference is 8. Determine the value of the smaller number, which is smaller. 29, so what's our answer going to be? 29. Questions on that? Yes.
Okay, so if you had, alright, if the sum is 66,
Uh-huh.
half of that is 33.
Okay.
And the difference is 8.
Okay.
All I did was add 4 to 33 and subtract 1 to 33. And I got
That could work.
Is that gonna work like every time?
I don't know for certain. It's probably, it might get a little more complicated here. So they might not just say, the sum is this. They may say 2 times the smaller number and 4 times the larger is blah, blah, blah. And that'd be a lot harder to do in your head, right? If it's that easy and that straightforward, sure, that's going to work and that'll be fine. But maybe not every time.